For centuries, sailors told tales of gigantic waves that they encountered at sea. And for centuries, scientists didn't believe them. However, over time, evidence began to pile up, which suggested that the legends of these freak waves were in fact true. These waves are rare, still not well understood, and terrifying to ships and sailors because there's almost no way to detect or predict where or when they would occur. Learn more about rogue waves, how they were discovered, and how they occur on this episode of Everything Everywhere Daily. This episode is sponsored by NerdWallet.
Nerds!
When it comes to general knowledge and history, you know I've got you covered. But who do you turn to when you need smart financial decisions? If your answer is NerdWallet, then you're absolutely right. And if it's not, let me change your mind. The nerds at NerdWallet have spent thousands of hours researching and reviewing over 1,300 financial products. And they have the tools you need to make smarter financial decisions. Looking for a credit card? Go beyond the basic comparisons, filter for features that matter to you, and read in-depth reviews. Ready to choose a high-yield savings account? Get access to exclusive deals and compare rates, bonuses, and more. House hunting? View today's top mortgage rates for your home sweet home. Make the Nerds your go-to resource for smart financial decisions. Head to nerdwallet.com/learn more. NerdWallet. Finance smarter. Disclosure. NerdWallet Compare Incorporated, NMLS 1617539.
What do Mattel, Banana Republic, ButcherBox, and Glossier all have in common? They power their businesses with Shopify. Shopify is the most innovative and scaled commerce platform on the planet that also happens to have the best converting checkout on the planet. And that's no industry secret. That's Shopify. Learn more at shopify.com/enterprise.
As there might be some confusion on the topic, I should begin by explaining what a rogue wave is and, perhaps more importantly, what it isn't. A rogue wave is an isolated wave found in open water that is significantly larger than all surrounding waves. It's defined by its extreme amplitude or height, which means that the slope of the wave is very steep. And they are also very short-term, often dissipating soon after they're formed. Rogue waves are extremely dangerous to any ship that might encounter them. To get hit by a rogue wave will likely result in severe damage or even sinking. It is not a tsunami, which is a very different phenomenon. A tsunami is defined by its very long wavelength. In the open ocean, most ships won't even notice a tsunami, which is why when there's a tsunami warning, ships are advised to go out to sea. A tsunami isn't a high wall of water that crashes onto a beach. It's more like an extreme tide that just keeps coming in and doesn't stop. Tsunamis are only deadly when they hit land, and you can find many videos online that show tsunamis in action. Rogue waves are also not necessarily caused by storms. Storms can create large waves, and rogue waves can be found in storms, but they can also be found in somewhat calm seas. Rogue waves, also called freak waves and killer waves, are officially defined as any wave that is more than twice the significant wave height. Significant wave height is defined as the mean of the largest third of waves. In the ocean, there are always many different waves of varying sizes. Some are small ripples and others are large swells. When scientists or sailors want to describe the sea conditions, just measuring one wave won't give a good picture of how rough the sea is. So instead of focusing on all waves, they focus on the bigger ones, which are the most noticeable and potentially dangerous. So a rogue wave is much bigger than the biggest waves in the ocean, regardless of what the conditions happen to be. The history of our knowledge of rogue waves has been an odd one. For centuries, sailors have reported seeing gigantic waves on the open ocean, and these reports were generally considered the equivalent of sea monsters or mermaids. The most famous report came from a 19th century French explorer, Jules Dumont d'Urville. He was a botanist and cartographer who had sailed on multiple expeditions and was president of the Geographical Society of Paris. He was highly regarded in the scientific world. In 1826, he reported seeing a wave that was 33 meters or 108 feet high. 3 other witnesses on the ship confirmed his observation. When he made his report public, he was ridiculed. His ridicule stemmed from the fact that oceanographers at the time used a model known as the Gaussian sea model or standard linear model to predict wave heights. According to this model, even in a severe storm, you would never see a wave greater than 15 meters or about 49 feet. A wave of 30 meters or 98 feet would be something that could only happen about once every 10,000 years. It should also be noted that humans never observe the vast majority of ocean waves. They take place in the open sea where the odds are there are no ships. Despite the report by d'Urville, these huge waves were mostly forgotten and not taken seriously despite the periodic reports of them. In 1921, a 70-foot freak wave was reported in the North Pacific, and in 1923, waves of 80 feet or maybe higher were recorded in the North Atlantic. In 1942, the RMS Queen Mary was supposedly hit broadside by a 92-foot wave that almost capsized her. In 1956, the captain of the cargo vessel Junior reported an estimated 100-foot high wave about 100 miles off Cape Hatteras, North Carolina. And in 1966, windows were smashed 80 feet above the waterline of the Italian ocean liner SS Michelangelo. It killed 3 people and tore a hole in the ship. The first person who took these reports seriously was Professor Lawrence Draper of the National Institute of Oceanography, who published a paper titled Freak Ocean Waves in 1966. Instead of just dismissing the reports, he considered the possibility that they might exist, and in fact concluded that they very well could exist, and said that waves, quote, can exceed by an appreciable amount the maximum values which have been accepted in responsible circles, end quote. He also noted the possibility of the opposite effect, which he called a freak wave hole. Instead of an extreme wave peak, he posited the existence of an extreme wave trough, something which, as of today, has never been reported at sea. With this paper, freak waves had gone from the realm of legend to at least the realm of theory. However, it still wasn't a core part of the science of oceanography. It wasn't mentioned in textbooks, and there really wasn't anything that could be studied. Until there was some actual data, it was stuck in the realm of theory. And all that changed on New Year's Day, 1995. The Draupner platform, which was a support platform for a gas pipeline off the coast of Norway in the North Sea, was equipped with laser instruments to measure wave heights. Built by the company Statoil, it was designed to withstand a 64-foot wave, which they believed would only occur once every 10,000 years. At 3 p.m., the instruments measured a wave that was 25.6 meters or 84 feet high. The wave slightly damaged the platform, confirming that this was real and not just an instrument malfunction. The significant wave height at the time in the area was only 12 meters or 39 feet, indicating that this freak wave was twice as large. This was hard data that changed everything. Now oceanographers had to adjust their models, and these freak or rogue waves suddenly became one of the hottest areas of study. The next bit of data came in the year 2000, when a British research vessel, the RSS Discovery, measured a 29-meter or 95-foot wave off the coast of Scotland in the North Atlantic. After several years, a paper was finally released on the observed wave, which concluded, quote, none of the state-of-the-art weather forecasts and wave models, the information which all ships, oil rigs, fisheries, and passenger boats rely, had predicted these behemoths. According to all the theoretical models at the time under this particular set of weather conditions, waves of this size should not have existed. End quote. Now that rogue waves were confirmed to exist, they suddenly provided an explanation for a series of mysterious disappearances. Ships had disappeared at sea for centuries. That wasn't unheard of, and more often than not, they would sink due to an unexpected storm. However, in the 20th century, with the advent of ships with radios, such disappearances became rare. If a ship experienced a storm or hit an iceberg like the Titanic, they usually had plenty of time to radio for help. However, there were still occasional cases in which a ship just vanished without explanation. In 1978, the MS München is believed to have been hit by a rogue wave and sank. All 28 crew on board were lost. The ship was never found, save for some lifeboats that were hanging 20 meters or 66 feet above the waterline. Given the damage to the lifeboat, it's believed that a wave significantly larger than that must have hit the ship. In 1900, 3 lighthouse keepers at the Flannan Isles Lighthouse in Scotland disappeared without a trace. Evidence of wave damage was found in the lighthouse 34 meters or 112 feet above sea level. The National Oceanic and Atmospheric Administration compiled a list of 50 cases that they believe were probably caused by rogue waves. With better data from Earth observation satellites and more ship crews on the lookout, more and more cases of rogue waves have come forward over the last 30 years since the Draupner wave. Researchers also realized why there were so few reports of rogue waves throughout history. Any ship that encountered one probably didn't leave any survivors to tell the tale. Today, the question is no longer if rogue waves exist. The question is now why they exist and how they are formed. It should be noted that there's still a lot we don't know about rogue waves. While we have multiple observations of rogue waves at this point, we don't have a lot, and the cases we can observe happen very infrequently. Several theories have been proposed to explain rogue waves. Nothing is definitive at this point, so take everything with a grain of salt. The most popular theory is constructive interference. This theory suggests that rogue waves form when multiple smaller waves coincide perfectly. When waves meet in phase, their crests align and combine to form a much larger wave. Another theory suggests non-linear focusing. Non-linear focusing occurs when wave energy becomes concentrated in one wave, causing it to grow disproportionately large compared to surrounding waves. This can happen due to the interaction between waves of different frequencies. The effect is particularly strong in deep water where waves of varying lengths can transfer energy in such a way that one wave grows while others shrink. Another theory is bathymetric focusing. Bathymetry refers to the underwater topography or the shape of the ocean floor. In certain regions where there are underwater ridges or sudden changes in seafloor depth, waves can focus and converge, leading to an amplification of their energy. This focusing effect can increase the probability of rogue waves forming in these areas. And yet another theory posits that there's nothing strange going on at all. This theory holds that rogue waves are just a natural part of the distribution of wave heights, albeit at the extreme end, and people just didn't consider it. Research into rogue waves has found several interesting things. And one is that such waves don't just happen in the ocean. They can exist on lakes as well. There is a type of wave that isn't quite a rogue wave, which is known as a three sisters. These are three large waves that hit in quick succession. One theory is that the Edmund Fitzgerald, which sank in 1975 on Lake Superior, was hit by a three-sister wave. Computer simulations, which again you have to take with a bit of a grain of salt, have suggested that there might be several thousand rogue waves that appear and disappear on the high seas every day. It's just that we never see them because there are no ships at the right time and the right place. In 2004, data collected from European Space Agency satellites over a 3-week period observed 10 waves of 25 meters or 82 feet or higher. I should end by noting the most extreme wave ever recorded, so far. On November 17, 2020, a buoy off the coast of Ucluelet, British Columbia, recorded a wave that was 17.6 meters or 58 feet high. Surrounding waves were only about 6 meters or 20 feet high. This made the rogue wave 2.93 times larger than the surrounding waves. This isn't the largest wave per se, and it's not as big as the Draupner wave, but the Draupner wave was during a storm, and this wasn't. Again, you have to take this with a grain of salt because our knowledge of extreme waves is sketchy, but there are some unverified reports that one wave in the Black Sea in 2004 may have been 3.9 times the height of its surrounding waves. Odds are that waves much larger than this have appeared recently, but nobody was there to observe them. Rogue waves are fascinating and dangerous natural phenomenon that continue to challenge our understanding of ocean dynamics. Their ability to appear without warning and immense destructive power make them a serious threat to maritime activity. Over the course of a century, they have gone from fable to theory to fact and are now one of the most interesting current areas of oceanographic research. The executive producer of Everything Everywhere Daily is Charles Daniel. The associate producers are Benji Long and Cameron Kieffer. I want to give a big shout out to everyone who supports the show over on Patreon, including the show's producers. Your support helps me put out a show every single day. And also, Patreon is currently the only place where Everything Everywhere daily merchandise is available to the top tier of supporters. If you'd like to talk to other listeners of the show and members of the Completionist Club, you can join the Everything Everywhere Daily Facebook group or Discord server. Links to everything are in the show notes.